All right, that's all. So let us start. Before we have a good discussion, actually, we want to have some further results. So first of all, this one. That we don't know if we have a function of a single random variable. Today, we will have the next one. And the next one focuses on one function of two random variables. Well, so this is the topic of supplement 2. Focus on one function with two random variables. So this is the goal we want to do. And likewise, I should let you know, we have the supplement. So it doesn't mean I will go through all the details. So I may jump. And later, I will jump to some example only. For example, this one. Z equal to sum of the two observations. Well, of course, we may have the other possible candidate to serve as the functions. X plus y, right? So here we may have these. And maybe have the others, for example, x minus y, or ratio or multiplication. Well, so for these, what to do? Again, we want to derive CDF first. So step 1, CDF. And step 2, so step 1, CDF, and step 2, if we want to have it, you can perform differentiation. Maybe we have 3 steps in the past, but this time, derive CDF, and second one, differentiation with respect to the variable, so that you have a PDF. The goal for us actually we want to find PDF. Well, here we want to know, still we have these, because we have two random variables. So of course we have x and we have y. To derive z, for example, equal to x plus y. Maybe we need to focus on some region, for example, the region or this region. So any kind of region we want to focus on that region to have the integration. Well, so first of all, this is the example we want to reach. Z equal to x plus y. Maybe for some example, it will allow you to check further, but let us show this. And maybe for some equation, we have some shifty version, but at least focus on this. Z equal to x plus y. So CDF first. This is step 1. CDF, right? Step 1, CDF, so x plus y lower than the specified variable z. So of course, what to do? If we want to find the region here, dz. This one, we have an equation x plus y equal to z. Okay, and because of this, x plus y lower than or equal to z. All right, so that says we should have a region here. Is it okay? So first of all, talking about dz. dz, in fact, it should be this region. And the region here, we find the line first. The line actually is equal. However, lower than or equal to z, of course, it should be this region with the shaded area, right? So about dz with the shaded area here, any questions? No, right? So let me have 1 second to discuss for each pair. Alright, so discuss about DZ and DZ. And for you maybe discuss for this pair, or maybe for the three. Alright, and discuss for each pair. And right now I'm not sure why I cannot see Evans. So sure you can check it. DZ. Of course, if we have discussion, just try to talk. Because we will have a class observation since 10 to 11 today. So, first of all, I want to share by H2. So, first of all, let me share rule 1. Shall we? About DZ, is it okay? Now, okay? You didn't get it? So, later I will check it with the rule 1. Good 2. Good, thank you. And good 3. Alright. And good 4. Alex, about DZ? Okay, alright. So, good 1. Maybe we need to check it. So the region here, if we want to check region, we can use X. So if we use X lower than or equal to Z minus Y. So that says X. Using this line, it should be the left-hand side, not the right-hand side. For example, a point here, using X. Lower than or equal to should be the left-hand side. So left-hand side, of course, the region here. And you can try Y should be actually the lower part, not the upper part. So that's why it should be the region here. So DZ. Is it okay? So DZ, in fact, if we have this, we will have the setting because we have X first and then Y. So X first, it says X from negative infinity to the point. The point X equal to Z minus Y. So that's why we have Z minus Y for X. And for Y, actually, this time, no restriction. So we will have infinity to infinity. Negative infinity to positive infinity. So that's why we will have the range here. Well, if we have DZ, then we can set the range for X and then range for Y. About the setting, is it okay? Y from negative? Because Y is no restriction. If we have X first, X to the point, and then someone like talking about Y this time, no, we can start from negative to x1. Even we have X here, but X set the limitation first. So for Y, we have the limitation first. All right. So about the limits X first. So we have negative infinity to Z minus Y. And then we check range for Y. So it will be the entire axis for Y axis. About the second, any questions? So let me check. We're free. Oh, we're free, right? So okay. Good. And Alice, okay? Sure, thank you. And Kevin? Again for you. All right, so here we have the range setting, then we have all of these. All right, so in fact, CDF here. And then we need to perform differentiation. Perform differentiation, then how to do?